So in this video series, we're going to discuss everything with rational equations, rational expressions. We're going to look at simplifying them. We're going to look at adding and subtracting, multiplying and dividing. And we're going to look at how we write our answers. We're going to look at excluded values, which are part of the domain. And then we're going to, another video series will be built into the slides that will pertain to all of the application when we're discussing work, formula, work problems, and distance rate time. So those are our objectives. And so this video will represent these three topics. So we'll go ahead and get started. What you want to do is when you're looking at a ratio with expressions, with variables, with constants, you want to think about factor as much as you can. Okay, so I'm going to write this as x times x plus 1, and the denominator is x times x plus 1, x minus 1. Remember that this is a difference of squares, so remember how it factors. Now, before I do any type of dividing or simplifying, okay, I want to state my excluded values, which is part of my domain. What we're trying to do here is we're trying to state which values of x will cause the denominator to go to 0. And remember, we do not want it to go to 0 because it's going to create an undefined or a hole in the graph. So we want to avoid anything that's going to cause the denominator to go to 0. So we've got to figure out what those are. To do that, you're going to take each part of a variable. In this case, there's x, so we're going to set it equal to 0. So we're going to say x is equal to 0. That means 0 would cause the denominator to go to 0 or become 0. So x cannot be 0, comma. Let's look at the next one, x plus 1. X plus 1, set it equal to 0. Solve, you're going to get x equal negative 1. X cannot be negative 1, comma. We've got another one, which is x minus 1. We set it equal to 0 and solve, we get 1 as an answer. So x cannot be 1. The order doesn't really matter with that. If you can list them from least to greatest, that would probably be the best. Those are your excluded values. So x can be everything else in regard to real numbers except for negative 1, 0, and 1. Now that you've stated those, your next item is to simplify. So you're looking at what will divide out. Okay, well this x will divide out with this x, leaving me with this x left over. So that's going to be part of my answer. And then this x plus 1 and this x plus 1 should divide out. And you're left with x minus 1 in the denominator. And there is your simplified expression coupled with your excluded values. I'd want to see both of those when you simplify rational expressions. Next one, 5x minus 20 divided by 3x minus 12. Let's go ahead and factor the numerator. So we'll factor out a 5. That'll be 5 times x minus 4. Factor out the 3. It'll be 3 times x minus 4. Excluded values, which is part of your domain. X cannot be. Well, let's take the only, these are the only two factors below, and only one of them has a variable, and that's x minus 4. So when you take x minus 4 and set it equal to 0, you're going to get x equal 4. So that means x cannot be 4 in this expression when we're substituting values for the domain. So x cannot be 4. We can have every other real number possible, but 4 will cause it to go to 0 in the denominator. Now that you have it factored, now that you have the excluded values of the domain stated, these will divide out, and you're left with 5 divided by 3, coupled with the excluded value. The next one, we look at the numerator, and we're going to factor, so that'll be x plus 5, x minus 5. We know that because that's a difference of squares. we see the 4x minus 20, so we're going to factor out a 4 to give us x minus 5. Excluded values, which is part of your domain, is I'm seeing just x minus 5. That's the only expression with the variable. Solve, I get x equal 5, so therefore x cannot be 5. Now that I have everything factored, I've stated my domain. I look and see what will divide out. The x minus 5s will divide out. And what are you left with? X plus 5 in the numerator, 4 in the denominator, coupled with the excluded values. With this one, we have a trinomial in the numerator, trinomial in the denominator. We're looking to factor as much as we can, so it looks like a 3 will divide out of both of those. So that'd be x squared minus 3x minus 18 divided by, factor out a 3, we've got x squared minus 2x, and that should be should be 24. Okay, and so then we're looking at the numerator, x squared minus 3x minus 18. So we're looking at factors of negative 18 that add to give you negative 3. So that would be negative 6 and positive 3. So 3 multiplied by, since a is 1, remember we can go to just these factors here, x minus 6, x plus 3, divided by the original factor of 3. Now I'm looking for factors of negative 24 that add to give me negative 2. And that would be 6 and 4. And that would be negative 6, positive 4. All right, so now that we have those stated, or is factored, let's go ahead and look for our excluded values, which is part of our domain. And so I'm just going to erase these here so I can write. So I'm looking at the denominators, remember? So x minus 6 is equal to 0, so x is equal to 6. And x plus 4 is equal to 0, so x is equal to negative 4. So x cannot be negative 4 and 6. So there's your domain. And then you come back over here and you look and you see these 3's will divide out, the x minus 6's will divide out, and you're left with x plus 3 divided by x plus 4, and that's all you can do. A very common mistake people make is they look at this and they think, well, I'm just going to divide out those x's. Well, you cannot do that because that x is being added to 3. And that x is added to 4. So we cannot cancel out those x's or divide them out. We are left here along with the excluded values. Here we've got an 8 minus x and an x minus 8. Those look a little interesting, right? One, they just kind of look in reverse. Well, what you have is this 8 minus x. If you wrote it, if you would rewrite it, you would have negative x plus 8 and x plus 2 and x minus 8 and x minus 2. Well, since it's in the numerator, I can take care of that in a little bit. I want to look at the denominator. And so my excluded values, part of my domain. So I'm looking at x minus 8 is equal to 0, so x is 8. X minus 2 is equal to 0, so x is 2. So x cannot be 2 and 8. So I've stated those. Now I'll come back over here and I'll see that the x plus 2 and the x minus 2 will not divide out. But if I factor out a negative 1 from here, that's going to give me x minus 8. Negative x divided by 1 is negative 1. 8 divided by negative 1 is negative 8. Now if you look, you'll see these do divide out. So we can write it as negative 1 multiplied by x plus 2 divided by x minus 2. Or you can look at it and distribute and get negative x minus 2 and x minus 2. Those are not the same. So I would take it as this, or I would take it as that, as a simplified expression along with the domain. This next one, we're looking at multiplying, because if you remember, the last few that we looked at were just single rational expressions. Now we're looking at multiplying. I'd like for you to hold off on multiplying this out. I do not want you to make parentheses and distribute the 4x to those. I don't want you to do that first. I want you to look at how you can factor everything as much as you can first. So the 4x, I can't do anything with that one. The 14x plus 7, they both have a factor of 7. So that would give me 2x plus 1. And the 8x plus 4, they both have a factor of 4. So that's going to give me 2x plus 1 and multiplied by 6. Now once we go through that factoring process, again, remember we're looking at the denominator. And we're looking at where we have variables, and then we're going to set those equal to 0 to figure out our excluded values. Well, the only one with an excluded value would be 2x plus 1. So 2x plus 1 is equal to 0. I'm going to subtract 1 and then divide by 2. So x is negative 1/2, so therefore x cannot be negative 1/2, or it's going to cause the denominator to go to 0. Now we can start to simplify, okay? We've already stated our excluded values, we've factored, now let's try to simplify. Well, this 2x plus 1 and 2x plus 1 will divide out. Now you're left with 4 multiplied by x multiplied by 7 divided by 4 times 6. Well, these 4's will divide out. So then what you're left with is 7x divided by 6, which we cannot simplify anymore, along with the excluded values. I need to see both of those when we're simplifying. I need to see your simplified answer, and I need to see your excluded values. All right, determine the excluded values again with multiplying. So I want to think, how much is 12x minus 20? I want to simplify as much as I can. You always want to think, can I divide out 12 from both of those? 12 and 20, the answer is no. So the greatest factor would be 4. So that would be 3x minus 5 divided by 5x multiplied by 6 divided by, so 9x minus 15. So 3 is the greatest factor, so that'd be 3x minus 5. So now you're thinking excluded values of your domain. X cannot be, okay, so I'm looking here. I see 5x, that has a variable, so x cannot be 0. And I also see 3x minus 5, set it equal to 0. I get 3x equal 5. I'm going to add the 5 over and then divide by 3, so I get 5/3. So x cannot be 0, and x cannot be 5/3. Now once you're finished with that, we have found the excluded values, we have factored, now we need to simplify. The 3x minus 5's will divide out. So you're left with 4 multiplied by 6 divided by 5x multiplied by 3. Well, the 3 will divide the 6 2 times, so you're left with 4 times 2, which is 8 divided by 5x. And 8 divided by 5x is your simplified form along with your excluded values of your domain. Let's look at another one. So we want to factor as much as we can. So x squared minus 25 should be x plus 5, x minus 5. That's a difference of squares. Divided by, all right, this is x squared plus x minus 20. So remember, you're thinking factors of negative 20 that add to give you 1. So that'd be 5 and 4, with 4 being negative. So that would be x plus 5, x minus 4. Remember, we can take them right from there because a is 1. multiplied by, on these others, a is also 1. So you're looking at factors of 12 that add to give you 7. And that would be 4 and 3. So we would have x plus 4 and x plus 3. And then we've got negative 15. Add to give you negative 2. So 5 and 3, negative 5 and positive 3. So x minus 5, x plus 3. All right, we have those, so I'm going to erase. And let's look at our excluded values. What can x not be? Well, you can kind of look here and you can see, well, x can't be negative 5. X cannot be 4. X cannot be 5. And x cannot be negative 3. So if you wanted to list those in order, least to greatest, you would say negative 5, negative 3, 4, and 5. Those are the values that x cannot be, or else we create 0 as a denominator value. Now that we have stated our excluded values and factored it, now we can look to simplify. So these x plus 5s will divide out. This x plus 3, they will divide out. This x minus 5, this x minus 5. So notice what you're left with. You're left with x plus 4 divided by x minus 4 as the expression, along with your excluded values. Here we see we've got a difference of squares here. A is 1, A is 1, A is 1. So here this is going to be x plus 7, x minus 7. And then this denominator here, you're looking for factors that multiply to give you negative 21 and add to give you 4. Well, that's going to be 7 and 3, x plus 7 and x minus 3. Here we're looking at that multiply to give you 15, but add to give you 8. So that has to be x plus 3, x plus 5. And then last, we've got multiply to give you negative 35 and add to give you negative 2. So that's going to be x minus 7 and x plus 5. What are your domain? Well, x cannot be negative 7. X cannot be 3. X cannot be 7. And x cannot be negative 5. So if I wrote those least to greatest, I'm not going to count off if you list those. It's just easier to recognize when you're looking or I'm looking at your results. So least to greatest, negative 7, negative 5, 3, and 7. X cannot be those. So now you're going back to your work because you have determined the excluded values, you have factored, now it's time to simplify. So these will divide out. X minus 7 will divide out. X plus 5, x plus 5. What are we left with? We're left with x plus 3 divided by x minus 3. Now let's look at some where we're dividing. It's the same idea, except think back when you were dividing rational numbers, okay? So when you're dividing fractions, and one way to divide is to multiply by, change from division to multiplication, and then multiply by the reciprocal, where you're reversing these. And then you would go through your process and see what you can divide out, right? So your answer would be 1/4. That's a process of dividing fractions. Well, these are fractions. They are rational expressions. So when we see the division I would encourage you to go ahead and there's really not a wrong way to do this one. You can factor everything first and then take the reciprocal of the second ratio. Or you can go ahead and, you could go ahead and factor everything. That's what I was saying, is you can go ahead and factor 3x minus 6, factor out the 3, you would have x minus 2, and then the 12 would be multiplied by x twice. Now, since you're still dividing, remember, we would have to, before we even do our excluded values, we would have to multiply by the reciprocal, so which give me 12 times x times x. It was in the denominator, now it's in the numerator. What was in the numerator here, you're going to find that that's now in the denominator. So this is what we're looking at now while we state our excluded values. So x cannot be. So I'm looking right here. X cannot be 0 because you would take 3x and set it equal to 0 and notice that x is 0. And then you would also look here. But you're really just looking here at that expression. So that's x minus 2. So x is equal to 2. There's your domain, your excluded values of your domain. And now you just go and start looking at what you can divide out. Okay, so one of the x's here, one of the x's here. X minus 2, x minus 2. So what you're left with is 8 multiplied by 12x divided by 3 times 3. So one of these 3's will divide that 12 to give you 4. So now you have 8 times 4x divided by 3, or 32x divided by 3. You would leave it as that mixed number along with the excluded values of your domain. So the only new part on this when you're dividing is that I just encouraged you to go ahead and factor everything, then change it to multiply by the reciprocal, and then we go through our process that we have been doing. So let's look at another one. Everything is factored in this case. So 6x plus 5 by x minus 3 divided by x minus 1 by x minus 3. We're going to change it to multiplication, and then remember we're going to take the reciprocal. Everything that was in the denominator is now in the numerator. Everything that was in the denominator or numerator is now in the denominator. Now we can look at what are our excluded values, which is part of our domain. X cannot be. All right, so remember we're looking here. X minus 1, so that means x cannot be 1. We're seeing x minus 3, notice here. So solve, we get x equal 3, so x cannot be 3. We're also looking here. So that would be 2x plus 7 is equal to 0. So let's subtract 7 and divide by 2. So x is equal to negative 7 halves. And then here we're looking and we would see that x cannot be negative 9. Negative 9 plus 9 would make 0. So now that we have all that, we have factored, we found our excluded values. Remember we changed from multiply to, or from divide to multiply. Then we found our excluded values. Now we can look to simplify. So this x minus 1, this x minus 1, this x minus 3, this x minus 3, this x plus 9, and this x plus 9. Looks like everything except for 6x plus 5 in the numerator and 2x plus 7 in the denominator, along with the excluded values. Okay, then there's one more, and this one's going to be a little bit more tedious because we're going to have to do some factoring, but notice that our a values are not 1. So we're going to see if we can divide out any factors, but if not, we have to go through our factor by grouping. So we're going to take the top expression and we're going to factor that. And so remember what you're looking for. Since we can't factor out a 5 from anything, you're taking a times c, and that's going to be negative 60. And you're looking for factors that add to give you 17. And so that'll be 20 and negative 3. And so remember, you're going to take 5x squared plus 20x plus a negative 3x minus 12. Remember, you rewrite the first term, rewrite the last term, group. So you're going to get 5. So you'll get x plus 4. Factor out a negative 3. You're going to get x plus 4. So you're going to have 5x minus 3 multiplied by x plus 4. That's what you'll have. So 5x minus 3 and x plus 4. Okay, so I'm going to go through each of them and just erase after I found them. All right, the denominator here is going to be 3 times negative 20. So remember, that's going to be negative 60, and it's got to add to 7. And so that's going to be 12 and negative 5. So we're going to rewrite the first term, 3x squared, and then write 12x plus a negative 5x minus 20. And we're going to group. So 3x, so that'll be x plus 4. Factor out the negative 5, that'll be x plus 4. So you'll have 3x minus 5 and x plus 4 as your factors. So 3x minus 5 and x plus 4. Okay, and then now we're going to go to the divisor. And we're going to look here. And so we can't factor a 5 out, so we'll say 5 times negative 3, so that'll be negative 15, and it's got to add to give me 2. So that'll be 5 and negative 3. So we'll have 5x squared plus 5x plus negative 3x minus 3. And we'll group. So that'll be 5x. So that'll be x plus 1. And then we'll factor out a negative 3, and that'll be x plus 1. So you'll have 5x minus 3 and x plus 1. So this is more of a tedious one where you're going to have to factor everything first, get it to a format to where you can then multiply by the reciprocal, state your excluded values, and then go ahead and divide out. So we've got 3 of the 4 complete. Now we're looking at the last one. So that'll be 15 times 15, and that's going to be 225. And remember, we're using our calculator to do that. It's got to add to give you negative 34. So remember, you would go to y equal, type in 225 divided by x in your calculator, and go to second graph, and you start looking for factors, and you'll see negative 9 and negative 25 will add to negative 34, but negative 9 times negative 25 gives you 225. So you'll have 15x squared minus 9x plus negative 25x plus 15. Group the first two, group the last two. Most you can take out is a 3x, so that'll be 5x minus 3. Factor out a negative 5, that'll be 5x minus 3. So you'll have 3x minus 5 and 5x minus 3. All right, so we've factored everything. Now we need to go ahead and take the reciprocal of this one. So we would have x plus 4, 5x minus 3. And in the case, just the case of time here, I'm just going to erase those and change it to multiply. And so we should have 3x minus 5 and 5x minus 3. They were both in the denominator. They're now in the numerator. Down here we would have 5x minus 3 and x plus 1. Those were both in the numerator. So let's state excluded values, part of our domain. What can x not be? So it looks like we're going to have a couple of fraction amounts. So if we look here, we're going to see that if we add the 5 and divide by 3, x cannot be 5/3. Here we're going to see x cannot be -4. Here we're going to see, well, let's add the 3, divide by 5, so that would x cannot be 3/5. And here we're going to have -1. So there's your domain. And then we go and look at what we can divide out. X plus 4, those will divide out. 5x minus 3, 5x minus 3, 3x minus 5, or 3x minus 5. So what we're left with is x plus 1 in the denominator, 5x minus 3 in the numerator. Again, that's a very tedious problem when there's lots of factoring, but I wanted you to see, how difficult they could become in all the factoring and the algebra that's involved there. So again, we look at your problem. If it's multiplying, we want to factor everything as much as we can, state our excluded values, then we can divide out what we see that are common factors. If we have a division problem like we have here in the last couple that we've worked, we can factor everything first, then we can multiply by the reciprocal. So remember, you're only reciprocating the divisor, which is the second ratio. And then you go through stating your excluded values. After you do that, after you take the reciprocal, you start stating your excluded values. Then when you're finished with that, you start to divide out your like factors. So this will conclude the video about simplifying, multiplying, and dividing rational expressions.